We can rewrite this expression as this mod 1000 equivalence. We'll separate 1000 into its two primes. So in order for this to be true, it must be true in both mod 8 and mod 125. In this first equivalence, we notice that when n is greater than or equal to 3, 2 to the n is 0 in mod 8. And likewise over here, 5 to the n is 0 in mod 125. So let's eliminate n equals 1 and 2 from our set of solutions. When n equals 1, our expression on the left is 7, which is not equivalent to n. And when n is equal to 2, this is 29 and not the same as 2 in mod 1000. So we can eliminate those two values of n and continue to solve these for n greater than or equal to 3. Since we know n is greater than or equal to 3, we have that 2 to the n is 0 in mod 8. So we can eliminate this first term, and now we're looking for 5 to the n is equivalent to n in mod 8. And again, 5 to the n is 0 in mod 125 for n greater than or equal to 3. That eliminates the second term, and now we're looking for 2 to the n is n in mod 125. We'll start with this one on the left. 5 to the 1 is 5. 5 squared is 25, which is 1 in mod 8. 5 cubed is 125. And since 120 is a multiple of 8, this is also 5 in mod 8. And we see that this is going to continue for higher powers of 5. So when our exponent n is an odd number, we have that 5 to the n is 5, and when it's even, we have 5 to the n is 1. On the right-hand side of this equivalence, n reduces to one of these numbers from 0 to 7, and we have a solution when n is 5 in mod 8, which means it's one of these numbers that fits this pattern that's 5 more than a multiple of 8. We can write this algebraically as 8 times some number a plus 5. Let's plug this back into our second equivalence. So replacing n with 8a plus 5, now we'll use our rules for exponents to break up this exponent. So this will be 2 to the power of 8 raised to the power of a multiplied by 2 to the 5th. 2 to the 8th is 256, and 256 is 6 more than a multiple of 125, so we'll replace this with 6 to the a, and we'll multiply this as 32. We want to figure out what this 6 to the a is in mod 125. We'll do this by writing this as 1 plus 5 raised to the a power. And now we'll use the binomial theorem. Our first term here is a choose 0 times 1 to the a. The next term is a choose 1, 1 to the a minus 1 times 5. Next we'll have a choose 2. I'm going to leave out the 1, and this will be 5 squared. Our next term has 5 cubed in it. That's going to be a multiple of 125, and so will all the next terms, up to the 8th term. These last terms are 0 in mod 125, so we'll ignore them, and we'll simplify this a bit. A choose 0 is 1, and 1 to the a is 1. A choose 1 is a, and here we have a 5. A choose 2 is a times a minus 1 over 2, and we're going to multiply this by 25. So we'll plug this expression for 6 to the a back into this equation up here. And we multiply this expression by 32. Now we'll distribute 32 over these three terms. To solve this equivalence for a, we'll note that if we have some number n that's 0 in mod 125, we know that this number n is also going to be a multiple of 5. So we'll start here and work our way back up to 125. And we'll continue multiplying this out and combining like terms. These are all multiples of 5, and I'll replace 32 with 2 and minus 8 with minus 3. Using guess and check, we see that our solution here is 4 in mod 5. Algebraically, we can write this as 4 more than a multiple of 5, or 5b plus 4. Now let's bring this back up to mod 125. Now we'll substitute this expression for a, and we'll expand this square. When I distribute this 25 over this 25b squared, we're going to get a multiple of 125, so I'll just replace that with 0. This will be 1000b, which is also 0 in mod 125. This third term gets us 400. This is 25. These two add up to 60, so I'll factor out a 10. This means that the product of these two factors is going to multiply to be a multiple of 125. The 10 will have one 5 in it, and we need 2 more 5s in the prime factorization of b plus 6. So b plus 6 is a multiple of 25. A solution here is b equals 19. We'll take this value of b and substitute it back in for a. This gives us a is equal to 99. And let's find our expression for n in terms of a. Here it is, 8a plus 5. Substituting 99, our answer is 797. If you'd like me to solve any other math contest problems, please leave them in the comments.